Welcome to our first Lunch and Learn session for 2022. We're excited to be back. I'd like to firstly begin by acknowledging the traditional owners and custodians of the land and those of the land that we are on, the peoples of the Kulin Nation. I also pay my respects to their elders past and present. So each week we talk to different specialists. Today we have Leanne Griffin, Ecologiq Senior Program Manager, and she's with Ravi Ravitharan, Professor of Practice and Director of Monash Institute of Railway Technology, and Alison Dilger, Senior Sustainability Advisor on Regional Rail Revival and Geelong Fast Rail. Just to set the scene for a lot of what we'll do this year, over 3.5 million tonnes of plastic is used each year, and about 13% of that is recycled. Over 1 million tonnes of that is single-use plastic that is much more likely to go to landfill. So we need to flip the economic equation so that environmentally friendly solutions can become drivers for industry. Hence, plastic is high on Ecologiq's list of priorities, and we're looking to incorporate and optimise for inclusion into transport infrastructure projects. So today we're talking about recycled composite plastic sleepers. We'll be here for half an hour and there's 10 minutes of questions at the end. The session is being recorded and we'll put that up on the Knowledge Hub. So over to you, Leanne, take it away.
Thanks, Cheryl, and thanks, Alison and Ravi, for joining us today. So my first question goes out to you, Ravi, and I was wondering if you could just help set the scene in terms of what exactly are recycled plastic composite sleepers, and why are they important technology that we should be considering for infrastructure?
Thank you, Leanne. The composite recycled plastic sleeper is made out of plastics which have come out of wastage in a agricultural wastage, and we have used to really develop a sleeper that can replace timber sleeper. So that is the plastic sleeper evolution at the moment in the country, and it has been trialed and tested for various specific requirements in railway, and that's what we are talking about here, Leanne.
Thanks, Ravi. So I'll come back to that. I know that there's some discussions around a next generation sleeper, but we'll come back to that one next time, because really, as you said, we're here today to talk about the current use of recycled plastic composite sleepers, which is really that timber replacement or low speed kind of replacement. So Alison, you're involved in one of the very first projects to implement these sleepers in a non-trial basis. Can you tell us a little bit about what the Triple R project is trying to do and your journey in terms of how you got here?
Thanks, Leanne. So we have two projects within Triple R that have purchased composite sleepers and are about to install them, and a third that is also looking at this product. So one of the projects is the SCOO, or Shepparton Corridor Upgrade Project, and how they came about on this project was we had seen some of the trial work during the development phase and working with AGM. They gave us our advice, overall sustainability advice, and in that was some discussion around these composite sleepers. And based off that advice, and we put a technical requirement into our PS&TR set for them to trial the composite sleepers within that project. So that project involves a new stabling yard at Shepparton, and these sleepers are really at the moment are just approved for the slow speed applications like stabling yards or sidings. So it was a perfect opportunity to trial that. The other project is the Walloo project, and that project had already been sort of locked in terms of PS&TRs prior to us really getting into this discussion around composite sleepers. So it wasn't a requirement under their PS&TRs, but it's a little bit of an interesting story. So there was unfortunately a non-conformance in another area of sustainability on the project, and as part of the negotiations for dealing with that non-conformance, it was agreed that the Walloo project would include composite sleepers in the Warm Pond stabling yard, which became part of their scope of work. So we took a little bit of an advantage of something that didn't go quite so well to try and get another good outcome for recycled materials.
That's great. Thanks, Alison. That's a good example of, I guess, taking an issue and turning it into a bit of an opportunity to trial some emerging materials. So Ravi, just back to you. So I just wondered, you've been involved in some of the testing and certainly the understanding of to get the composite sleeper to where it is now. So the DuraTrack sleeper that went through a few different trials and now has that type approval with both V-Line and MTM. So could you tell us a little bit about what that looked like and kind of the last couple of years of what's gone into getting the approval process for that low speed timber replacement kind of sleeper?
So Leanne, this journey started in 2015 when Public Transport Victoria decided that for the tourist and heritage railways, we should consider composite plastic sleepers because of the limitation in timber sleeper. So they supported a project with Monash Institute of Railway Technology to come up with guidelines. How do you really identify appropriate plastic sleeper that can be utilized? Plastic sleepers have been utilized in the world for a long time, but here we are talking about recycled plastic sleepers. So how do we really create a plastic sleeper that can meet the tourist and heritage railway requirement? And that work continued on, and there were two major contributors who were really trying to meet the requirements to do that timber replacement plastic sleepers. And one of the company is called Integrated Recycling, and their plastic sleeper has gone through various stages, and now they've got a DuraTrack plastic sleeper, which is not only meeting the tourist and heritage railway requirement. Following that, there was a significant amount of testing was done through Sustainability Victoria grant to identify what are the sleepers, what these plastic sleepers can meet in a railway environment, a normal railway environment, to get provisional approval to utilize. Especially Queensland Rail was really instigating that particular requirement, and then MTM and V-Line gave provisional requirement for these integrated recycled plastic sleepers called DuraTrack. We also got some funding from the Sustainability Victoria to not only to do the laboratory testing, to really monitor the field trials, to look at these sleepers which are utilized in these various environments. And mainly they were used in a low speed siding yard application. ARTC came on board and helped us to put it on mainline track near Tottenham, where around 20 plus plastic sleepers were replaced, where normally a concrete sleeper would have gone in. But this is an area where a 23-ton axle load at a average speed, about 40 kilometers per hour. And the sleepers have been there for more than a year, and it has performed very well. And we have real clear understanding of what sort of loads go into these plastic sleepers that has been in there. And the plan is to leave that as long as we can before that section will be re-sleepered with other type of sleepers if required.
Great, thanks, Ravi. And so, Alison, from a project perspective, what are the main benefits and what are the main reasons that really kind of incentivized you to take on the uptake, I guess, of the sleepers?
Yeah, so within the sustainability agenda within RPV, we have 5 focus areas, and one of those focus areas within the sustainability team is materials, and how and the recycled first policy came into place in 2020 in response to the fact we can't ship our plastics overseas and just sort of forget about them anymore. So the industry as a whole had to respond, and one of the ways to do that was trying to take recycled materials into the big build, and we definitely want to support that. So yeah, I think for us, that's the advantage. It's trying to build that knowledge base, provide opportunities for these products to be used, and build confidence in the products, so that we know in the world of recycled materials, there's 101 horror stories of where things haven't gone wrong, right? Sorry. So we want to try and provide the evidence or the proof that yes, they can work. These are the applications, and as Ravi said, build up that confidence in the product to see it used more broadly across the rail system as a whole.
That's great. Thanks.
So Leanne, if I just jump in there, I think as Alison highlighted, 1 kilometer of track which will have about 1,500 sleepers, let's assume, and it's about 70 tons of recycled plastic can be utilized for that space. So that is coming out of a landfill, which is equivalent to about 210 cubic meters or 150 trees. So these are the benefit of utilizing the composite plastic sleepers, and railway is contributing in a significant way to minimize the damage that we do to our environment.
Thanks, Ravi. That was very similar. I was going to ask you about the potential impact that this could have on the industry, which is the take up of these sleepers in a widespread way. So is there anything additional that you could kind of add there in terms of what this could mean for both the I guess the usage of plastic waste, but also the rail industry if there is widespread uptake of composite sleepers?
So I think, again, I stress that the current plastic sleepers have been mainly a replacement of a timber sleeper. So if you look at it, in the country, we have got about 11 million timber sleepers, and they had to be replaced at some stage. And do we replace with timber, which we don't have? There is an opportunity here that we can replace them with a plastic sleeper, composite plastic sleeper. So it's not a virgin plastic, it's a composite plastic sleepers. And as I highlighted before, it is at the moment coming out of a agricultural waste created in Mildura in Victoria, and it is providing a significant benefit. But the advantage, and again, 40,000 kilometers of track we have, and that is growing day by day with a significant investment coming into rail capital improvements. So that is the first part. Wherever the timber sleepers, we can actually look at using these composite plastic sleepers. The second part is if we can replace concrete sleeper, which is about 31.5 million concrete sleeper currently in the country. And that is also growing significantly. That is where the opportunities even further comes into the railway scene, and we can contribute in a significant way. It's just not only for Australian market. I think there's opportunities that we can, in the past, we used to send these the plastics that are curbside collected plastics to overseas. That cannot be done anymore, as Alison mentioned before. So we can actually send, rather than sending plastics, we can send plastic sleepers, composite plastic sleepers to other countries. And that is a great export market and job opportunity as well. Leanne?
That's great. Thanks, Ravi. And we will talk a little bit more about those next generation sleepers, or those concrete replacement sleepers, which are in an R&D phase at the moment. But Alison, just wondering from you, for other projects out there that are considering, from an Ecologiq perspective, and obviously from a Recycle First perspective, we would really want every project to be considering the use of recycled plastic composite sleepers right now in their current use, and then obviously kind of monitoring and being signing up for trials for those more kind of higher speed usages, and certainly into the future with the next generation sleeper. But for other project teams, what advice do you have to them if how to go about this? What do they need to know? How do they get the ball rolling to start really getting sleepers into projects?
Thanks, Leanne. So yeah, I think part of the reason for doing this today is, just to make people aware that we do have a type approval for some products, and that, because there's always when you're trying to do something new, there's that concern about the risk. So yes, as Ravi said, we've gone through a very extensive testing process, and we do have the proper type approvals in certain situations. One of the challenges is that these products do currently cost more because we're making on a very small scale. So again, by trying to look for all the opportunities to use them, we're hoping by providing a greater demand to the industry that we can reduce that cost. I think we've recently done some tenders for warm ponds duplication, and both the bidders were keen to pursue this as part of that project, even though we hadn't specified it in the PSNTR. So I think the construction industry is also catching on and really keen to support the recycled first agenda. So again, it's sort of about communicating with our project teams, letting them understand that this is not a risky product in the right applications, in that making sure that our contractors or constructors are aware of the product, and getting them keen to use it and make sure that it's costed in at the start, then that argument about cost, it's factored in, and not such concern. I mean, the other point to note is around the installation. So the current product doesn't have what's called jewelry. So this is something that the supplier is working on, but it means that it's a little bit more intensive to do the installation, because you have to, attach the jewelry, which is sort of the ties that hold it to the track or the ground. And so, from the constructor's point of view, there are a few things for them to work through with this current product. But again, getting that feedback back from the constructors helps us to feed through to Ecologiq and the suppliers and improve the product over time. So, we're Ecologiq and ourselves, we're very much about learning the barriers or any concerns that there are with the product, so that we can continue to work and improve and make sure we overcome those in time.
That's great. Thanks, Alison. I think you've touched on a couple of really good, important points there, which is the role that we have as projects and the influence that we can have in terms of helping these products and markets to scale and to grow, and that early stage feedback around what works and what doesn't is so important to be able to enable these markets going forward, so we can get better products and better technology for rail. So it's something, again, obviously we really want to promote that, and we really want to encourage people to consider that. So I just had a thought and then I just lost it. So I will actually ask you, Ravi, a question, which is around the performance of the sleepers, because we know that cost it can be an upfront barrier, but if it's costed in early, it's something that can really be considered as part of projects. And obviously, the more that we use these sleepers, the more that we create scale and market, the cheaper that they're going to get. But how do they stack up from a performance perspective against, say, the timber sleeper, or potentially against the concrete sleeper, even though at the moment we're not looking at a concrete sleeper replacement? Should project teams have any concerns around the performance and the safety of these sleepers?
I think, as Alison highlighted, the correct usage, the correct environment is critical. I think we cannot go and put these currently available sleepers into a high-speed, heavy axle load environment. I think that's why Alison has highlighted that they are using in a siding or a low-speed environment, which is critical. There's a bit of work has to be done to really understand how the better chemical formulation and manufacturing process to improve the plastic sleepers, and that is a research that you highlighted. Also, Alison mentioned about the jewelry, because current plastic sleepers are timber replacement, and though all the jewelry used in a timber environment, you can use it in a composite plastic sleeper as well, the Duratrack sleeper, which is what we are trialing, and we have trialed, and we are going to use it in the future. So the expected time delivery is about 3 times of timber sleeper. So it is a cost, initial cost is significant now, but the overall it is actually come down. And also with the scale that we are talking about, and if there are every siding, every low speed environment start utilizing composite plastic sleeper, the cost will come down. Manufacturing, as we all know, if the scale is there, we can actually improve the process. So that is the plan, and that is the way that the industry is going forward. The other thing is we can import these plastic slippers from anywhere. They are not really helping the environment here that we are trying to create the recycle, the issues with recyclable type of activities. And that's what is important. We need to really develop that capability, and that's what we are trying to do in this environment from the university perspective and with regard to the railway industry perspective as well. I don't know whether I covered your question enough here. I don't know whether I can go into much more detail about the next stage of the project, but I think I'll leave it at this stage.
Well, that's my next question, actually. So I will say, so just to all the participants, if you do have questions, please pop them in the chat. Any questions for Alison or Ravi, and we can ask them as we go. But while we're waiting for those questions to come in, Ravi, I'm just wondering, now seems like a good time to tell us a little bit about what comes next. So we've talked a bit about the timber replacement. It's a great opportunity to be using that right now, and obviously that's going to support that industry, and it's going to help scale that from a cost perspective. But what about a concrete replacement, a mainline replacement? What's in the pipeline in terms of that, and what are the opportunities for Victoria?
So on that regard, I think the current sleeper has got obviously the limitations are the strength, stiffness, fatigue performance to the level that we want if you are going to look for a concrete sleeper. In addition to that, the cast-in shoulder, that is a critical part, because rather than driving dog spikes or screws into the plastic sleeper, which will create some issues. And also looking at the manufacturing process of the whole thing, because in a plastic sleeper, there could be right in the middle of the plastic sleeper, there could be some low strength area. These are all part of the whole discussion about, we talk about those slow speed, low, axle load type of environment. So for that particular purpose, the work that we are currently doing is looking at the sleeper properties, both physical, mechanical, and functionality. I think that is the way that we are looking at it, so that we don't have to really replace the concrete sleeper with the same strength, because the concrete sleepers, all of us in the industry know that they are over-designed for the need. So to meet the current need, we actually identify what is the current composite sleeper is required. And the other thing I mentioned before, curbside collection plastics need not being used at the moment in the recycled composite plastic sleepers, and we want to bring that into it. And we also want to introduce reinforcement, but to make sure that the strength is being improved, and also still it is fully recyclable. So we are talking about circular economy, right? So even when the plastic sleepers are finished used in the railway, we want to make sure that they are recycled again to be utilized. So rather than just taking plastic from a landfill and putting on railway, and then we don't know what else to do after the timeline is finished, whether it's 50 years or whatever the timeline, we want to make sure that that is recycled again. So we are looking at whole of life costs and reduce the production cost as well. The other work that we are doing in that the next generation plastic sleeper to replace the concrete sleeper.
Great, thank you, Ravi. And just a question for you, Alison, that's come in on the chat. You mentioned jewelry before, that the kind of current sleeper doesn't have the jewelry that comes with it. Can you explain a little bit what that means in terms of what jewelry is and what it means in particular to this sleeper?
Okay, so I'm not a track expert, so I will give you my layperson interpretation of this. So the composite sleepers that we get now, as Ravi said, it's just like a long rectangle. Yeah, it's like a big timber sleeper. And the jewelry is the bits that you sort of put over the top to connect it to the track to hold it in place. And on concrete sleepers, when the concrete sleepers arrive, they have that jewelry already sort of partly attached to the sleeper. And then you just have to attach that, drive your spikes through into the track. Again, please, this is my lay understanding of it. So if I'm using the wrong terms, Ravi might be able to help me out. But yeah, so the composite plastic sleepers don't have anything attached to them. So you have to attach those tires or whatever they're called to the sleeper as well as to the track. So it's just a bit more, and you also have to drill into the sleeper to sort of make that connection. So it's just a little bit more labor intensive for the installation of those sleepers as a result.
Okay, great. Thanks, Alison. We've got a couple other questions that come in as well, so I will move
Leanne,
on.
can I just supplement? I think Alison is right. I think currently the sleeper, on top of the sleeper, there is a rail which goes on that one. The rail has to be mounted onto the sleeper, and we use a base plate, and screw spikes are used to really connect that rail. And that is the jewelry that Alison has been talking about before. And in a concrete sleeper, that is normal procedure for a timber sleeper. In a concrete sleeper, there's a cast-in shoulder, which is already casted into the sleeper. And that is the process. And that actually reduces the carbon footprint as well. because you are not really creating a lot of metal pieces which are really driven into the timber sleeper. So that is the advantage of cast in shoulder, and that is the next generation approach that we are going to go forward. Sorry.
That's okay. Thanks, Ravi. Just quickly, Alison, with the even though there is maybe additional jury requirements, does it change any ballast requirements or any of the track formation for plastic versus concrete, or is it all just pretty much stock standard?
You're getting way above my technical knowledge now, Leanne, I've got to admit. Not that I'm aware of, but I think we'd probably need the track designers here to answer that question properly.
Yeah.
I might just supplement that one. I think there is no change is required between a timber sleeper and a integrated recycled Eurotrack sleeper. So they just go replace. And as I said, Tottenham has got at the moment every 5 composite sleeper. There is a timber sleeper, just so that we can trial and make sure that things are all working together. And they didn't need any change at all. With the concrete sleeper, it varies. There are a low profile concrete sleeper or bigger sleepers. It might change the ballast height requirement if you want to really mix and match. Otherwise, it doesn't require any different change in this space.
Great, thanks, Ravi. We've got 3 questions in. 2 of them are related to fire, but one of them is also to do with international partnerships. And I think these might both be for you, Ravi. But the first one I want to start with is there any kind of, I don't know, Monash are looking into the next generation of composite sleepers, but is there any international partnerships that are going on around trialing composite sleepers in different environments, climates, weather, so that to build like a more, I guess, international understanding of how these sleepers perform?
At the moment, I think we are all in the stage of really finding the best solution, and there's no international partnership other than some of the railway systems have brought in international products just to trial between that against what is available in the country. With the fire, I think there is a requirement that they don't really ignite themselves. Like if somebody puts a fire on it, it just doesn't really propagate the fire. But in a bushfire situation, obviously it is like a timber sleeper. It won't really create more fire, but I think it will get melted, and that has been tested. Part of the testing requirement is to include that, and also it doesn't create any poisonous gas when they burn. If they burn, that is another requirement as well in the development.
Yeah, I think that's a really good point around the fire. So if these sleepers were being placed in high fire risk environments, certainly in areas that are prone to bushfire, what would be the advice that would need to be considered in terms of the selection of these sleepers?
Well, I think in a bushfire, the railway track itself will buckle. I think the rail itself is going to be prone to be in a difficult situation. So in that environment, I think any sleeper that you put in, even concrete sleeper, would actually have difficulties as well. So as long as they are meet the temperatures and environment that we face, other than bushfire, I think we don't have any advice to give other than saying that I think we had to avoid bushfires and help the environment so that we don't really get into that difficulty. That is the only advice that we can provide at the moment. And we made sure that these sleepers doesn't contribute to the fire situation. Yeah.
And so obviously is as part of that type approval process and that testing, the flammability and the fire resistance of these sleepers has been tested. It's been all part of that approval process. Is that correct?
That's right. Yes. I think that is part of a series of tests that has to be done to make sure that they are environmentally beneficial. I'm not sure each and individual type testing what they actually require, different organization, but that is part of the guidelines that we have provided to the DOT in the past.
Okay, great. Cheryl, is there any final questions, or is that our time up?
Yeah, that sort of wrapped it up, and that's probably good timing because we're coming to a close. I'm just going to share the question slide so that if anyone has any further questions, they can send them to our Ecologiq address, and we'll get those answers for you. If you've got anything for Alison or Ravi, we'll happily pass those on. As I said earlier, plastics are important in the environmental considerations and on a high priority for Ecologiq. So our next session, we're talking to Jack Manning, who works on one of the Level Crossing Alliances, about the installation of e-mesh. So it has been installed on a number of projects. He'll be talking about the Lilydale and Muralbark project. I know some road projects have introduced it, but there's huge opportunities for this product. So we'll be chatting to Jack. So please, you don't need to register again if you're already registered, but you will receive a notification early next week about this session. So thank you very much to Alison, Ravi and Leanne. That was a great start. And I think it would be fabulous to actually chat to Alison and maybe even Ravi later in the year once the sleepers have been installed. So it'd be fabulous to get that experience as well. So
I was just thinking that, Cheryl, we should definitely check back in and see how the process has gone, and hopefully it's all great. Yeah.
So we'll do, this is our first, we'll probably do 3 this year, and that would probably be the 3rd session, which would be sort of September, October. So yeah, if you're happy to do that. But thank you again, and thank you everyone for attending, and we'll see you next Friday. Thank you.
Thanks so much.
Thank you very much.
Thank you.
Thanks.
Bye.